Hi folks, welcome to my channel, The Average Dermadoc. Let's begin the show. Before going in detail about intrinsic versus extrinsic aging, first we will see what is aging. It is a progressive, inevitable and irreversible decline in the physiological functions of the body that occurs with time, leading to increased vulnerability to disease and death. What is meant by inevitable? It means no one can avoid aging, no one can bring back your age and time, which is meant by irreversible decline. That's why never waste your time and load your life with regrets. You have already sacrificed a lot of your age and time. That's why you are here doing your residency. If you are an average student and opened your books all by yourself and tried to study, it will consume a lot of time even now in your residency. Instead of that, just spend half an hour on my YouTube channel. You are going to learn one question per day for sure. It means you will definitely pass your exams if you learn one question per day. Rest of the 23 and a half hours you can have your life to fill it with memories. This aging process, skin conveys to the external world by its appearance. What is the pathogenesis or molecular mechanisms of skin aging? Main one is oxidative stress. On exposure to UV radiation, reactive oxygen species stimulates downstream signaling pathways like mitogen activated protein kinase, nuclear factor kappa beta, transcription factor activator protein 1, AP1, which will increase the gene transcription of MMP, nothing but matrix metalloproteinases like collagenases, which destroys the collagen. This AP1 also reduces the expression of transforming growth factor beta, which is necessary for synthesis of collagen, ultimately leading to reduction in collagen levels. If there is no collagen in skin, no one is there to hold the water. So the skin will lose its suppleness. Suppleness means soft, flexible nature of the skin. It is because of collagen. Now this collagen is reduced because of oxidative stress. Second one is DNA damage. UV exposure causes DNA damage, which leads to skin aging, and mutations, which leads to carcinogenesis. That's why old age people are more prone to benign, pre-malignant and malignant lesions. On exposure to UVB photons, nucleotides undergo structural changes leading to DNA defects. What can we understand by this word? On absorption of UVB photon, a molecule which absorbs light is called a chromophore. Here DNA is acting as a natural chromophore for UV radiation, leading to its defects. Telomere shortening with each cell division leads to cellular senescence, ultimately cell death. A senescent cell means which has lost its capacity to divide and lost its capacity of normal functioning, which will ultimately undergo apoptosis and then cell death. UV radiation also produces reactive oxygen species, which leads to telomere mutation, which also leads to ultimately cellular senescence and cell death. What is telomere? Why it is going to lead to cellular senescence? This RE is for repetitive nucleotide sequences that protects the tips of the chromosomes from degradation. T for telomere, T for tips of the chromosome protection. If chromosomes gets degraded, ultimately cell can't divide and will enter senescent stage. MicroRNA, that is nothing but non-coding RNA. Dysregulation also leads to cellular senescence, reduction in hyaluronic acid and number and function of skin capillaries. Next, advanced glycation end products accumulation. Sugars like glucose, fructose binds to proteins, lipids and nucleic acids, ultimately leading to advanced glycation end products. What is HbA1c? It is also glycated hemoglobin. This glycated proteins, lipids, nucleic acids are of waste. They don't perform their normal functioning. For example, glycated elastin and collagen will lead to reduced elasticity, tensile strength and hydration. I already told you collagen holds water and provides hydration. Here elastin provides elasticity, which means if we pull our skin and leave, it will go to its normal place like a spring. Thus, this property is called elasticity, which is given by elastin. This glycated collagen is of no use. It is also resistant to matrix metalloproteinases. Normal collagen is going to get degraded, as we can see here, because of oxidative stress. Abnormal unwanted collagen like glycated collagen is staying in our body because it is resistant to matrix metalloproteinases. That's why celebrities in many interviews will say they won't eat sugar at all, because to avoid this glycated end products. Chronic low-grade inflammation, also called as inflammaging. If we are getting exposed daily, chronically to UV radiation, it will lead to oxidative stress, which leads to keratinocyte damage and oxidized lipids. Normally, lipids has to form a barrier function to our skin. These oxidized lipids are very dangerous. It will further aggravate oxidative stress. It will lead to complement activation, finally leading to chronic inflammation and dermal damage. Epigenetic processes controls the expression of genes and play an important role in aging. What is difference between genetics and epigenetics? Genetics is study of gene as a whole, structure, functioning, everything. Epigenetics means study of expression of genes. For example, if a pregnant lady is getting poor nutrition, drinking alcohol, exposing herself to UV radiation, all these environmental factors will alter the epigenetic processes and alters the expression of genes within the baby, and baby will get affected. This is called epigenetic processes. Whereas genetics means if mother has a defective gene, it is going to get inherited to her baby. That is nothing but genetic inheritance. Here, what are the hallmarks of epigenetics? For senescence and aging. Senescence means occurring at cellular level. That's why we have to use the word cellular senescence. Aging is at organ level. If all the cells became senescent, organ won't function, and it is called an aged organ. What are the hallmarks? Covalent histone modification or loss by methylation or acetylation. Chromatin remodeling. Altered DNA methylation. Breakdown of nuclear lamina. What is nuclear lamina? This is a structural proteins network which supports the nuclear envelope. These proteins are called laminins. If these proteins are getting defective because of defective genes, those diseases are called laminopathies. If, for example, lamin A is getting defective because of mutation in gene LMNA gene, it will lead to Hutchinson-Gilford progeria syndrome. Because of this lamin A defect, nuclear lamina won't be proper. There will be breakdown of nuclear lamina, ultimately nuclear envelope. This abnormal mutated protein lamin A is called progeria. Pro means early, geria means old age. That's why study of disease in old age is called geriatrics. As aging is occurring very early, that's why they called it as the protein progerin, and the disease Hutchinson-Gilford progeria syndrome. For example, another laminopathy is leukodystrophy because of defective lamin B protein, because of defect in gene lamin B, LMNB. Here, after knowing this pathogenesis, we clearly understood that external factors like UV exposure and internal factors like cell division, telomere shortening is happening. That means there is two types of skin aging, both of which run together. Whoever born will undergo naturally intrinsic aging, At any point of time, someone has to get exposed to environmental factors. We'll also have extrinsic aging. Intrinsic aging will be happening naturally in everyone. Extrinsic aging may get super added to it or accelerates this intrinsic aging. Intrinsic aging is also called physiological aging. Extrinsic aging is called photoaging because the main factor here is UV radiation, that is sun exposure. Intrinsic aging is seen in photoprotected areas like inner arms and thighs where sunlight will not fall on them. Extrinsic aging obviously in photo exposed areas like face, V area of neck and dorsum of hand. All these areas will be undergoing naturally intrinsic aging. Upon that, extrinsic aging like photoaging will also occur. Intrinsic aging is because of cellular senescence, because of genetic factors and hormonal factors. Extrinsic aging is because of sun exposure, pollution, smoking and poor nutrition. That's why a healthy diet is very important to postpone this extrinsic aging. Intrinsic aging, no one can stop, but we can just postpone the extrinsic aging. That's why celebrities who takes proper healthy diet will look younger compared to their normal age. Epidermis will become thin in intrinsic aging. Why? Ultimately, when one ages, the proliferative capacity reduces. There will be no proliferation of keratinocytes, melanocytes, fibroblasts, leading to thin epidermis. Whereas in photoaging, it may show atrophy or hyperplasia depending on its clinical variant. In both the aging processes, collagen, elastin and all the extracellular matrix substances will get reduced. In intrinsic aging, skin will become thin, dry, pale with fine wrinkles, increased fragility, laxity and elasticity. There will be absent dyspigmentation, more prone to benign neoplasms. Hallmark neoplasm is benign neoplasm is seborrheic keratosis. I already told you there are two clinical variants in extrinsic aging. One is atrophic variant, which is very similar to intrinsic aging, like fine wrinkles, increased fragility, laxity, reduced elasticity. As the name itself is saying, atrophy, there will be atrophy. If skin gets atrophy, blood vessels will be easily visible, telangiectasias and focal dyspigmentation. All these three comes under a triad called poikiloderma. Atrophic variant is mainly seen in skin types 1 and 2. The only difference here is it will have dyspigmentation and wrinkling will be extensive because natural aging is happening inside, super added on that our extrinsic aging is happening. There will be more prone to pre-malignant and malignancies. The hallmark pre-malignancy in atrophic aging, A for atrophy, A for actinic keratosis. This is because of proliferative exhaustion. In extrinsic aging, body will have some proliferative capacity, but that will also get exhausted in atrophic variant. Hypertrophic variant will still have protective hyperplasia, leading to thick leathery skin with coarse wrinkles and uniform tanning. There will be relatively lesser risk of malignancies. Hallmark feature of hypertrophic variant is solar or actinic elastosis. Actinic elastosis means accumulation of truncated elastin fibers within the dermis, leading to yellowish thick skin. Ultimately, a single patient will have a combination of intrinsic and both the variants of extrinsic aging. Remember the channel name. Don't forget to like, share and subscribe. Thank you. Hasta la vista. Das vidania.